Hey Jafri, how's it going?
Everything good. What about you?
Doing well.
Okay.
Doing well.
You got the result for second exam?
No, no results yet, but we'll get them on Thursday.
Thursday.
I'm feeling pretty
Actually,
confident. Did you?
yeah, I saw like what up only up to 10. Let me show you here. You can check whether you did like this.
Mm-hmm.
This is, for example, your first question of exam 2.
Yep.
You did like this.
Oh, let me see. I think I got. I think I did this one wrong. I got. Let me see. I think I reversed them. The oxidation numbers on that.
Okay, because hydrogen, when it is combined with non-metal, it has a +1 charge.
Mm-hmm.
Only -1 when it is with metal.
Yeah, I got that one wrong. I believe.
Okay.
I'm pretty sure I reversed that. Yep.
All others are correct, right?
Yeah, I got these. Yeah, this one here. I'm just checking my work.
Oh, sorry, this one I put wrong thing. It's a -2. Sorry, here I had, but here I put something wrong here. It's going to be -2 here.
Yeah, I'm just trying to find my work. Let me see.
Okay, don't worry.
Yeah,
I'm going to send you
I believe I
after
got this.
completing it.
Yeah, answer D. Um. Yeah. Yeah, I think maybe that's probably one of the only ones I got wrong then. That
Which
oxidation
one?
That the card.
Oxidation number.
The what was it? C2H2.
Mm-hmm. Okay.
Yeah. Yeah.
What
Unfortunately.
about question number 3?
Yeah, I got that. I got 8 ml for that one. Yep.
4.
Yeah, number 4. So, yeah, I put acid, base, both, and then acid. Yep, I did that. Yep.
Question 5. This is ionic. This is net ionic. This is Ca,
Yes.
not Cd. It looks like Cd.
Yes, I got
Let's
that.
see. 6, answer A.
Yeah. Yes, I did. Yep.
7,
Yes, I. That one was.
this is 2.4, 3.66.
Yes. Yep.
Okay. 8 is B, 128.
Let's see. Yeah. Yes, I put that. Yep.
9 is D, 9.2. Actually, I was reading 9.28, which is 9.3, but
Yeah.
answer choice,
Yeah, I agree with you. I wrote this down on my paper, and I was just like,
Mhm.
oh, all right, the closest one is 9.2.
Yeah, so I also took
I
the
remember
closest
that.
one. Okay, number 10, I
Yep.
got A is the correct answer, 35.
Yep. Yes, sir.
Okay, I only did up to 10, so I will check another 10.
Yeah, no
So let's
worries.
start chapter 7, okay?
Okay. Thank you, Jafri. I appreciate it.
Okay, no problem. So let's start chapter 7.
Okay.
And because I already have that one, so no problem, I'm going here
Yep.
directly, opening this one.
Yeah, I got a copy of it just printed out on my desk,
Mhm.
so I can refer to the data and stuff like that.
Okay, so question number 7.5. No, sorry, 7.7. What is the wavelength? So they are asking the wavelength, lambda. in nanometer. They're asking in nanometer.
Yep.
Of light having a frequency. Frequency is given here, and that is 8.6 times 10 to the power 13 hertz. Hertz, cycle per second, or just per second, all of them are same. Okay, in the A part they are asking wavelength.
Mm-hmm.
In the B part they are asking what is the frequency of light having a wavelength. They are giving another thing. So let's first try this one. The velocity of light is 3.0. I am taking 10 to the power 8
Yep.
per second.
That's the constant, yeah?
Constant. So nu is equal to C over lambda. Or I can say lambda is equal to C over nu, frequency. So just plug in the value. So I'm going to plug in the value. C is 3 into 10 to the power 8 meter per second. And this one is 8.6 times 10 to the power 13 cycle per second. Per second, you can say.
Mm-hmm. Mm-hmm.
Now just solve it and see. But the answer, right now the answer I will get in meter, not in nanometer.
Meters. Okay. Yeah, I'm getting
3 exponent 8.
.488 times 10 to the minus 2, 3, 4,
3.48. So because they are using two significant figures, so I'm just rounding it to 3.5
Mm-hmm.
times 10 to the power 1, 2, 3, 4, 5, 6. Minus 6.
Yep,
Right?
minus 6 meters.
This is meter. And now in order to convert this into nanometer, you are going to multiply this by 10 to the power minus 9, and it will become nanometer. So this will give you 3.5. Oh, sorry, not minus 9, plus 9, sorry, because I am converting into nanometer. 3.5 times 10 to the power 3, or you can say 3500, 3500 nanometer. You have the same answer?
3.5 times 10 to the 3 nanometers. Okay. Yep. Yes.
Okay, so that's
Yep.
we are getting like this one.
Yep.
Nanometer. Okay, now the next one is, so it's clear? Answer you will get in the meter.
Mm-hmm.
And if they are asking in nanometer, then you have to convert it. Why? Because we are using the velocity of light in meter per second. The constant is in meter per second.
Got it. And 1 meter is equal to 1 times 10 to the 9 nanometers. Yeah?
Nanometers.
Okay.
And now 7.15. Let's add this one now.
Okay.
A photon has a wavelength of 624 nanometer.
Mm-hmm.
So wavelength is 624 nanometer. Okay, is equal to 624 times 10 to the power 9 minus 9 meter. When you are converting nanometer to meter, the power is minus 9. Because meter is bigger, you are converting from a small unit to bigger units. Power is negative.
Yep.
When you are converting bigger to smaller, power is going to be positive. Calculate the energy of the photon in joules. So you have to calculate the energy in joules. Which formula is good for this problem?
Okay. Let me see. We could use, since we have the we could use E equals hc over lambda, or
yes,
right? E
yeah,
equals
you're
hc
right.
over lambda.
Because the main formula is h nu, and which is equal to also hc over lambda. So we are going to use this one.
Mm-hmm.
Now what is the value of h, Planck's constant? The value of Planck's constant is, I think, 6.63 times 10 to the power minus 34 joules second. Just double check this one.
Yep. Yeah, you're right.
And now just plug in the value.
And it's the unit of Planck's
Joules
constant.
per second, I think.
Yeah,
Am I right?
It says it's joules, and then it's multiplied by seconds.
Okay, so I was right. And then joules second, okay?
Joules second.
Otherwise,
okay.
we can figure out, it's not a big deal.
Yeah.
And the 3 times 10 to the power 3.0 times 10 to the power, let me write 3.0. 3.0 times 10 to the power 8 meters per second, and lambda is how much? 624, and now you have to use in the meter, not in the non-nanometer,
So we'll use
because we are using this one. So look at the unit, meter and meter cancel, am I right?
Right.
Second inverse and second also cancel. And now the only surviving unit is joules, and we want the answer in joules.
Well,
So it means, is it clear?
Oh, okay.
6.63 exponent
Yeah,
minus
I missed the unit there. Just a second. Okay. I'm getting 3.187
Yeah,
5 times
right.
10 to the minus 19.
Yes, you're right. So you can write 3.19 or 3.2, it's up to you. Because if I take this velocity of light, two significant figure, then I can write 3.2. Otherwise, I can write 3.19. Because all others are three significant figure, am I right?
Right. Yep.
So now let's go to the next question.
That's right. We'll go to 6.25.
Explain why elements produce their own characteristics colors when they emit photons. Okay, this one is, we have to explain it. So let's do this question here.
I remember you gave me a good image of the different energy levels, like this.
Yeah,
states.
that's good for, that's I gave you like energy levels thing. And the same thing apply, because normally we have the spectrum of hydrogen element, but also other elements apply the same thing. For example, n is equal to 1, n is equal to 2, n is equal to 3. So their energies of the orbit are not same for all of them. So for example, the first shell, second shell, third shell, if electron is coming from infinity or anywhere, and they're coming from maybe 10, 11, 7, whatever it is, coming to the first one, or they're coming from another one, all of them, so they have a different energy.
Yeah.
And because they have a different energy, their orbits energies are different. So when they come back by releasing energy, they emit a different frequency or different wavelength radiations.
Yeah.
Okay. For example, hydrogen first and second, the energy of n is equal to 1, n is equal to 2 is going to be different. And if I take another element, some other element, n1 and n2, that's going to be different. So depending on the difference in energies, they emit different types of color. Is it clear?
Yep.
Yeah. And now let's go to the .27.
Yep.
Is it possible for a fluorescent material to emit radiation in the ultraviolet region after absorbing visible light? Explain your answer. After absorbing visible light. Okay, first of all, is it possible for a fluorescent material to emit radiation in the ultraviolet region after absorbing visible light?
Okay.
Okay, first of all, we have to look like, I have to check this answer to confirm this one, but I will explain briefly. Because ultraviolet rays has a higher wavelength, sorry, lower wavelength.
Yep.
And lower wavelength means as compared to an higher frequency. Higher frequency. And the other one is visible. Visible is high, longer wavelength,
Yep.
and longer wavelength, low frequency. So it means what happens in this case, that ultraviolet, they are absorbing in the visible region. So they are absorbing low energy because they have low energy. Visible has low energy. Ultraviolet has high energy. High energy because it depends on the frequency. High energy. So what happens, they are asking, is it possible for a fluorescent material to emit radiations in the ultraviolet region after absorbing visible light? Explain your answer. I have to double check maybe some other phenomena, but it do not looks correct to me right now. Okay, but I'm going to double check this thing. Why I am thinking it's not, maybe some other phenomena is there, because in fluorescence there is also like a relaxation is there. So, but it looks like it's not going to possible right now. Why? For example, I'm going to give you example, but I have to double check. Maybe some other phenomena is there, so I have to double check this one.
Yeah.
I have to check. But let me explain a simple thing. Because normally, if you have, suppose you earn $500, okay? So, and in your pocket you have 500. So if you are going to some place short shopping, you can spend $700.
Right.
Because your total amount you have 500. You can spend less than 500, but not more than
But not more than what you
500.
have. Yep.
Yeah, the same thing is here, because the thing is, it is absorbing visible. Visible means like a less energy. It is absorbing visible. So it is going to, if it is going to emit, it has to emit like less energy, and less energy means can't emit UV. It looks like this.
Yeah, I think.
But there is another possibility. That's why I have to double check this one. That is, maybe the visible is just giving like a start.
Yep.
Is giving the start, and the electron goes to somewhere, and then it coming back to the lower. For example, electron is going from, it starts, goes to this higher level by you absorbing visible region, and now when it is coming back, it is coming to the further lower orbit. In that case, it is possible. So I have to double check and confirm this answer.
Yeah, it's.
Okay.
I was looking at I was trying to make sense of the solution manual, and
Look the solution what they are saying.
It says light emitted by fluorescent materials always has lower energy than the light striking the fluorescent substance. Absorption of visible light could not give rise to emitted ultraviolet light because the latter has higher energy. Yep.
Yeah. So, but I was looking like maybe like some other phenomena where electron is going from the third orbit to fourth, and then when coming back, falling to the further lower, like that one. But generally, I believe like this one, like 500, you can spend 700. So it means this assumption was right.
Yep.
That was right, right?
Yeah. Yeah, it just mentions that the reverse process, ultraviolet light producing visible light by fluorescence, is very common. and it just
Yeah.
it gives like an example of laundry detergents that contain materials called optical brighteners can make a white shirt look whiter and brighter than a similar shirt washed in ordinary detergent. I don't know, but
I
yeah,
didn't took that example. I just took 507 because I know
right.
visible has a lower energy, like less amount.
Mm-hmm.
Ultraviolet means now you have 500, but you want to spend 700.
Mm.
So it's not possible. Okay. Okay. So now let's go to
And fluorescent material that so that implies visible light. Is that right? Or
visible.
is that right? Like for a fluorescent material to emit radiation in the ultraviolet region.
Yeah, normally like because it's absorbed, visible, and gives like not only the ultraviolet, but it can give like the lower one. So it's going to give. It's better. It will absorb ultraviolet and give less energy visible,
Okay.
and that's why the material shine and gives like that one.
Okay.
First. Okay, now let's go to the 7.53. Am I right?
Yes. Yeah, it's been a long time for me doing these. I haven't. I remember.
An electron in a certain atom is in the n is equal to 2 quantum level. List the possible values of L and ML that it can have. Okay. Yeah, this one, let's explain this one. And I'm going to explain it and then you are going to give the answer, okay?
Okay.
Instead of directly giving the answer.
Yep.
And, okay, now this is about the quantum numbers. Quantum numbers. There are 4 quantum numbers. One is called principal quantum number, main quantum number you can see, denoted by n. And the value of n is equal to 1, 2, 3, and so on. Like the number of shell, first shell, second shell, third shell. This is the main quantum number. And it determines the energy of the electron in any orbit. The next is called azimuthal quantum number. Azimuthal quantum number. This is denoted by L. And the value of L is going to be start n minus 1 to n, like it's 0, 1, 2, 3, like this one. Like you can say n minus less than 1, starting from 0, and then 1, 2, 3, like this.
Okay.
When L is 0, it means it is S subshell. When L is 1, it means P subshell. When L is 2, it means D subshell. And when we have 3, it is in the F subshell. So because practically we have 4, but in case theoretically if I say G, then it's going to be 4, okay? But practically we have only 4 SPDF, so 0, 1, 2, 3. So it tells you about the subshell of the electron, in which subshell it is present.
Yep.
Now the ML, the third quantum number, is called magnetic quantum number. And the azimuthal quantum number is also sometimes called angular quantum number. So magnetic quantum number is denoted by M. And the value of M is minus L to plus L. You can also reverse the direction, plus L to minus L, doesn't matter. And 0, passing through 0. For example, if your L is 1, what are the possible values of M?
Be minus 1, 0, and 1.
So 3 possible values. And that's why when L is equal to 1, what is the subshell?
P.
P. And look, in subshell P, you have 3 things, Px, Py, and 3 orbitals are there. Px, Py, Pz.
PZ. Yep.
Yeah, so we did the 3 orbitals, Px, Py, and Pz. 3 directions, 3 things. So the 3 possibilities are there. If we have M is equal to, suppose L is equal to 0, what subshell you have?
S. S.
S. So how many directions is possible?
Is it just 2 or 1? I'm sorry.
Only one,
There's
because
only
0
one
do not have
orbital, yeah?
minus and plus, only one.
There's only one
So
orbital.
if L is equal to 0, there is only one possibility for M, 0. Because there is no negative 0, no positive 0. It's clear?
Okay.
And that's why when you write 1s, you make only one orbital.
Mm-hmm.
Okay?
Mm-hmm.
What about if L is equal to 1? What orbital you have?
P, right?
Oh, sorry, we did already. 2, I'm saying.
D.
D orbital. So how many directions are possible, M value? How many?
5. Wait.
5,
on.
starting from -2, -1,
Yep. 0.
0, plus 1,
and 2.
plus 2, like this. So now let's go, and also, of course, they are not asking in this question, but let's do the last quantum number, spin quantum number,
Mm-hmm.
denoted by S. Sometimes the M is also known as, they also denote this M as ML. So same thing, remember, ML. So ML and M is same thing. So S is spin quantum number, and spin quantum number is denoted by S, and it has only two possible values. Either it is going to be plus half or minus half. We can assume anything, it is not fixed. Suppose if I am assuming this one as a plus half, so opposite is going to be minus half. But I can also oppose it in the opposite direction. Okay?
Got it.
So only two possibilities. And now let's see this question. 7.53, right?
Mm-hmm.
Now you tell me the answer.
It's saying an electron in a certain atom is in the n equals 2 quantum level. So if n is equal to 2, that means that it's like, let's see, it's in the second period, right?
No, not, it doesn't involve the second period. It is the what subshell you have. Electron is in which subshell? Oh, sorry, not subshell, sorry. This is in the second shell, not the period, okay? Second shell, you're right, but it's not the period. Second shell. Like K shell, first L shell, all right?
Okay.
List the possible values of L and M. So what is the L possible value? Okay, one thing I forget to tell you about L. The possible value of L is also, you can say the value of L is like this one. L is going to be equal to from 0 to n minus 1. From 0 to n minus 1. So for example, if your shell is first shell, so what is the value of n for first shell?
If it's 1, I'm sorry.
Hmm.
So it'd be 0 to 1. Right?
0, no, not 0 to 1.
Or
What is the possible value of L?
minus
0.
1?
And what about 1 minus 1 is also 0. So only one possible value.
0. Okay.
0. There is no other possible. So the possible values of L in any given shell is, you can find by this formula. L is equal to 0 to n minus 1. So let's go back here, this question. They are asking possible values of L.
Okay.
So what possible values of L should be?
So if it's 2,
0 to minus 1.
0 to n, which is 2, so minus 1. So 2 minus 1 is 1. So it'd be 0 to 1.
0 to 1. So only two possible values. It means the second shell has only S and P. And look, when you write the electronic configuration, you only write 2S and 2P. You don't have 2D. Am I right? There is no 2D.
No.
Only we have 2S and 2P.
Right.
In the first shell, you have only S, 1S.
Mm-hmm.
Even we don't have 1P there.
Yep.
So this is the possible. Okay. They're also asking possible value of ML.
ML. Okay. And we said that ML is the magnetic quantum number.
Minus L
0 and
to
positive.
passing to 0 and plus L.
Okay.
So what are...
So since L is, so would it be like minus 1, 0, and positive 1, or no?
Look here, in this case, in the n is equal to 2. So because n is equal to 2, now we have two possible values, am I right?
Mm-hmm.
0 and 1. So if it is 0, we have what values? The possible value of ml is going to be 0. Let's take l is equal to 0. So ml is equal to what? It's only going to be 0, 0, because 0 to n minus 1. So 0 minus, what you will get this one. Oh, sorry, I made a mistake here. Not this one. ml is equal to minus l to plus l passing through 0.
So it'd just be
So if
0.
l is equal to 0, ml is equal to 0. But also we have l is equal to 1. So what are the other possible values?
Okay, it would be -1, 0, and +1.
So we have, so the possible values is -1, 0, and +1. We can have these possible values, okay? For L is equal to 0, ML is equal to 0. For L is equal to 1, we have -1, 0, and +1. What is the answer in this case? Check the answer. They are writing separately or combining them only? Writing only for, writing separately for L is equal to 0 and L is equal to 1?
It gave a pretty lengthy explanation. It says the angular momentum quantum number 1 can have an integral value from 0 to n minus 1. So just like you said, in this case, n equals 2, so the allowed values of the angular momentum quantum number L, oh okay, it wasn't 1, L are 0 and 1, so that was right. And then each allowed value of the angular momentum quantum number labels a subshell. Within a given subshell, label L, there are 2 L plus 1 allowed energy states or orbitals, each labeled by a different value of the magnetic quantum number. The allowed values run from, okay, just like you said, -L to 0 to plus L, whole numbers only. Let's see. Yeah, so the magnetic quantum number are -1, 0, and 1. Okay.
Okay, that's right.
Yeah.
And also, because one thing which I missed, and when you were reading the answer, you said the possible value of m is equal to, what you said, 2l plus 1, am I right?
That's
I also read this one, am I right?
Yeah, it says within a given subshell, label L, there are 2L plus 1 allowed energy states or orbitals.
Okay, orbitals, you're right. Okay, now look, this one I'm going to explain. For example, for s orbital, okay, what is the value of L? 0. Value of L is 0. So what about the 2L plus 1?
That's 2 times 0 is 0, and then plus 1 is 1.
1. What about for p orbital?
P is 1. So
2, okay, so 2 times 1 is 2, plus 1 will give you what?
It's 3.
3. And look, in s orbital, you have only one orbital. In p, you have 3. It is the same thing, just like I told you, -L, 0, and plus L.
Yeah.
This is they are doing in different way, okay? Like 3 orbitals. Is it clear?
Yes.
Okay, now read the 7.55.
All right. It's saying give the values of the quantum numbers associated with the following orbitals, and they have A, B, and C. So it's a 3-part question.
Give the values of the quantum numbers associated with the following orbitals. 2p, give the quantum number. Okay, so you have to give all the possible values, okay? So give the values of the quantum numbers associated with the following. So let's start with the 2p one. 2p, okay?
Okay.
And because they are not saying any particular quantum number, so we are going to mention all of them. So what is all of them? Means n, l, m, ml, and s. So what is the n value here?
All right. 2. Right.
2. What about the l value here?
Let me think. So it'd be SPD. So it would be
L, I told you start with the 0.
0, 1,
1, 2,
2,
3 like
3.
that. Hmm.
So if it's D, it'd be 0, 1, 2, right?
Hmm. Hmm.
Is
But
that
here it is P.
P? 0 is S. Okay, so P is going to be 1.
Is going to be 1. Okay. What
Oh,
about ML values?
okay. ML is going to be, since we said it was 2L plus 1, so it'd be,
That's going to tell you the
no?
orbit. But
The
what
orbit.
are the possible values? You have to for possible value it better you use this one.
Okay. So minus 1, 0, and plus 1.
Minus 1, 0 and plus 1. What about the spin quantum number?
Wouldn't it be like there are 6 possible, right?
No, the spin quantum number is only 2 values are there.
Okay.
Either minus half or plus half. There is no other possibility. It's clear?
Yes.
So in this case, when the electron is in 2p, only these combination. Okay, normally the combination we write N, L, ML, and S like this. First number represent N, second represent L, third. So these combination are possible because you have only one possible value of N. Am I right?
Mm-hmm.
It's 2. You only have one possible values of L here.
Yep.
But for ML, you have 3 possible values. So I can put any one. Minus 1. And spin number, I can put minus half. Okay. Or I can put 2, 1, minus half. Sorry, minus 1 and plus half. I can also put like 2, 1 and plus 1. Sorry, plus, no, don't write, but it's a plus 1 and plus half. I can also write 2, 1, plus 1
And
minus half.
Right.
And so all these possible are correct. But if I write like this, these are correct, okay?
And even
If
with
I write
0,
2,
right?
1, yes, I'm writing 2, 1.
Yep.
And now I'm writing like a 2 plus half. Is it correct or not for this situation?
Oh, let me look. Yep, they're saying for A, 2P.
Because electron is in the 2p. So
Yep.
I gave you the 4 quantum numbers. Do it make sense or not?
Yes,
Is
it
it
did.
possible or not?
Wait, this one right here?
Yes. The first number is N, second is L, then ML, and then S. Spin quantum
No,
number.
because this is the one that's
2 is not
picking
possible
up a.
because if L is equal to 1, ML cannot be 2. So this is wrong, right? So I know this is not possible, right? I'm
Yes.
writing another one. I'm writing 2, 1. I'm writing 0, and I'm writing minus half. Is this combination is correct or wrong?
Correct.
For this situation, that is correct because that
Correct.
is possible.
Yep.
Is it clear?
Yes.
So because they are saying list the possible values, so you have to write all of them, not only 4. Because I took 2, 1 definitely is going to be there. Now you have to change only what you have to change, ML and S. S you have only 2 possible value. L you start with the minus 1 as I did.
Yep.
Minus 1. I took minus half, my plus half, then I took 1, 1, plus half, minus half. Then I took 0. So I'm going to go next one, 2, 1, again 0. I can say plus half.
Yep.
Okay. So all of them I already have written here. Because we have 3 possible values of ML, and for each possible of ML, I have 2 possible values of S. But this is not possible. Okay, now I will give you another question similar to, we already have to do it here, so don't worry. Next is I'm going to do, this one I'm asking you to do,
Okay.
B part, 3s.
B.
Now the electron is in 3s.
Okay.
First tell me what are the possible values, tell me.
Okay.
Then we will make a combination, okay?
Okay. So I'll start with the n. The principal quantum number is 3, right?
Can we have another value here?
No.
No, only one. Okay, what about L?
L is, let me see. So since we have S, it's 0.
Can we have one also?
No.
No, only one possible. What about ML?
ML, so we could have just 0.
Just zero. So
Only
in
zero.
this case, only one possible. What about F?
We can have 2 possibilities. Plus
Yes.
1/2 or minus 1/2.
Or minus one. So can you make any? Of course, they are asking all of them, but let's start with. So
Okay.
I'm writing 3, which is n. What is the value of L? 1, 0. And because in this case, even ML is only one possible value. So these 3 are fixed. The next one I'm putting plus half. Is there any other possibility here?
Yeah, we could do 3, 0, 0, minus 1/2. And that would be it for this. Is that true?
This is only 2 possible. Yes, you're right. Because these 3 are fixed, already fixed. Only one values are there.
Mm-hmm.
Now let's do the another one. 5D.
5D. All right. So n
Now
would
first start with the N. N, L, ML, and S. Possible, all possible values.
all right. So n is 5, right? L would be 3.
Not 3,
Hold
I
on.
think.
0 is S, P, or 2. Sorry.
2.
2.
What about ML?
Let's see. So it'd be -2 or -2, -1, 0, +1, and +2. Sorry.
What about S?
Yeah, +1/2 and -1/2.
And minus 1/2. Okay, when you are making a combination, very simple, because I already told you we have to write N, L, ML, and S in the sequence, in the same order. So let's start with, because you already know 2 of them are fixed. So everyone has going to be 5 and 2.
Mm-hmm.
So I'm not going to repeat, all of them are going to have the same number, okay?
Yep.
Same, 5, 2, 5, 2, 5, 2. I'm going to now look ML. So I'm putting like ML what? -2. Okay, -2. And S I am writing plus half. Am I right?
Mm-hmm.
But
5,
again
2.
I have to put the -2, and now I have to change this one as a -half.
Yes.
So at least for -2 I already did. For each of ML value, you have 2 value of S. Am I right?
Yes.
It can be with this or it can be with this. So I put first this one. Now again I am going to do another one, -1. Of course the 5, 2, 5, 2 is all of them.
Yep. Totally
What will be
understood.
the next?
So it'd be -1, and then S would be, we could do -1/2. We could do +1/2.
And plus 1/2. That's correct.
Then we could do.
Now you can start with 0. Okay.
Mhm.
And in this sequence you can keep going and you are not going to miss anything. It's
Yep.
clear?
Yes. Yep.
Because with these 2 are fixed already, so we are not paying attention, just writing same thing. This one for each of them, because there are 1, 2, 3, 4, 5. So each one has 2. Each one has 2. So total I will get 10 combination.
10 combinations. Yep.
10 combination like this. Is it clear?
Yes.
Okay, now let's go to the, you did this one. 7.57. Let's see 7.57.
Okay. All right. It says discuss the similarities and differences between a 1s and a 2s orbital.
Okay, discuss the similarities and differences between 1s and 2s orbitals. Similarities is like both of them are spherical in shape, you can say. Shape is same. Both has one orbital. Both has only one orbital. their n value is different here. 1s has an n value of 1, 2s has n value of 2. Is clear?
Mm-hmm.
What about the L value? Both of them have same or different?
The same. 0.
0. Okay, that also same. Also, what about M value?
The same.
Same. And what about S? Also, they can have same values plus half or minus half.
Yeah, the spin.
But the energy of 2s is higher than the energy of 1s, you can also say. Read what they are telling the differences.
Okay.
Let's see.
It says it's a 2s orbital is larger than a 1s orbital. Both have
Yes,
this.
2s are okay. As you go further, it's become larger and larger. So that's good.
Yep. It says both have the same spherical shape, and the 1s orbital is lower in energy than the 2s.
Hmm.
So it's good. All those differences and similarities that you listed were it was more info than the manual is given. So that's good. That
Okay. So now what about 7.58?
Okay. It says what is the difference between a 2px and a 2py?
Mm-hmm.
So it'd be well the p.
What about the size? They have same size or different size?
Which one?
2px and 2py.
Do you want me to look up the answer?
No. First, you tell me. We will look later.
I think.
Number is 2. Am I right? Their n value is same. Am I right?
Right.
2 and 2, which is the principal quantum number. What about their L value for both of them?
The L value is the same. It would be
Same. Because it's px, py by L is equal to 1. So they have the same
1.
shape and same size. Because n is same, L is same, so they have the same size and same shape. And also they have the same energy because they both same orbitals. But their orientations are different.
Right, the orientation on.
Like for example, if I write the m in this case, let me have a write this one. This is 7.58. For m value, what is the m value for n is equal to 2, L is equal to 1. What is the m possible values? Minus L, 0 to plus L. So it means minus 1, 0 and plus 1.
Mm-hmm.
If I take this one as a px, in order I am taking, we can take any one, doesn't matter, but I'm just going by order. pz. So their direction is different. One is oriented on the x-axis, their lobes are on the x-axis.
Mm-hmm.
The other one is perpendicular to this one. Their orientation in space is different.
Is it
right?
Yeah, isn't a p orbital like a dumbbell shape or like kind of?
Yeah.
Like,
so both of them
right?
are dumbbell shape.
Mm-hmm.
That's why I say the same shape.
So px
But
would be
their
like
orientation
like
is different. They are perpendicular to each other. Suppose if I am taking one of them as in the x-axis, on the x-axis, their lobes are on the x. So other one may be on the y or z-axis,
Mm-hmm.
right?
Right.
So their orientations are different. Read the answer what they are saying.
It says the two orbitals are identical in size, shape, and energy, just like you said. They differ only in their orientation with respect to each other.
Yes.
And it asks, can you assign a specific value of the magnetic quantum number to these orbitals? What are the allowed values of the magnetic quantum number for the 2p subshell?
Okay, let me write.
That's what it
List
says.
all the possible subshells and orbitals associated with the principal quantum number n. List all the possible subshell and orbitals n. If n is equal to 5. Okay. Okay, no problem. So let's start with, like we did like in the beginning,
Mm-hmm.
all possible values, but we know that in this case, one thing is fixed and that is n. And what they are saying? 5. So when n is 5, what is the possible value of L? Because the possible value of L is going to be from 0 to n minus 1.
So 0 to 4.
0 to 4. So it means 0, 1, 2, 3, and 4, right?
Mm-hmm.
Possible values are 0 to 1, 2, 3, 1, 0, 1, 2, 3, 4. Okay, even 4 is there, but I don't know what the book is saying, because it represents 0 represent S, this represent P, this represent D, this represent F. Practically we have only 4. If I say 4, it may be theoretical or imaginary, you can say G. Okay, we will just later look at one. And now what about the M? For each of them, L, for if L is equal to 0, so M is equal to 0. If L is equal to 1, M is equal to minus 1, 0, and plus 1. If L is equal to 2, we know M is equal to minus 2, minus 1, 0, and plus 1. For if M is equal to 3, L is equal to 3, M is equal to minus 3,
Mm-hmm.
minus 2, minus 1, 0. This is F orbital.
Yep.
Plus 1, plus 2, plus 3. G is not, we don't use that one. Just look the answer. What they are using this G or not? Because
Yep,
practically
they're
we not
using 5G. Yep.
5G, am I right?
Yes.
So they are also using that one.
Yeah.
Because theoretically it's going to be there. So read the answer, what they're saying?
Yeah, it just says the allowed values of L are 0, 1, 2, 3, and 4, and these correspond to the 5S, 5P, 5D, 5F, and 5G subshells, and then these subshells each have 1, 3, 5, 7, and 9 orbitals respectively. So that's
Yes, you're
like
right.
1, 3, 5,
Okay.
7, and
Yes. For example, if I take L is equal to 4 also, which is G,
9. Mm-hmm.
G orbital, we are going to M is going to from minus 4, minus 3, minus 2, minus 1, 0, then plus 1, plus 2, plus 3, plus 4, 9. 9 is going to be. So the possible values of this one is from minus 1 to plus L time. It's clear?
Yes, sir.
Or we can also use this formula. Let me double check this one. How many possible, this is possible values. I think this is 2L plus 1, I think. Let me double check whether it's going to be correct or not. For example, if it is 2L plus 1, if it is S orbital, what is the value of L?
If it's the S orbital,
Hmm.
the value of M would be 0.
Because 2 times 0 is 0 plus 1 is 1, am I right?
1.
Only M is going to be 0, but it will give only one orbital. Possible values.
Mm-hmm.
One possible value. I'm not saying 1, but it's one possible value. If I'm taking M is equal to 4, so possible values of M is equal to 2 times 4, which is 8 plus 1, 9 possible values. 9
Mm-hmm.
possible values. And look, we have 9 from minus 4 to plus 4 passing through 0.
Yep, 2L.
Clear?
Yep, 2L
Plus
plus
ones.
1. Yep.
Yeah, it will tell you how many orbitals, you can say how many orbitals are going to be there. So in this case, 9 orbitals. If G orbital exists, if any time it will exist, it's going to be 9 orbitals. Okay.
Mm-hmm. Mm-hmm.
Okay, now let's go to the next one.
We got 2.6 or 7.61. It says calculate the total number of electrons that can occupy, and then it's got like a 4 part, so A, B, C, and D. So let's see. 1 S orbital.
To calculate the total number of electrons that can occupy, okay, 1 S orbital, A.
So we know
What
that
do you think?
we know that 2 electrons can do it, right? Because
Yes.
it'd be like one, like the spin. There's 2, right? 1 electron would be.
Okay,
for
let's
one
make the
spin.
formula for this and
Okay.
try, okay? Let's take, what is the possible values of L here is 0, am I right? For s orbital, what is the possible values?
Of L, you want?
L. L value is 0, am I right?
0, right.
If I write like 2L plus 1, what I will get?
1.
So I'm putting like 2L plus 1 and multiplied by 2. So let's see. 2,
Oh, it'd be 2 then.
2 times 0 is 0 plus 1 is 1, and you will get 2, and we can accommodate 2 electrons. Let's try the other one.
Okay.
For p orbital,
Mm-hmm.
what is the value of L for p?
1.
1. Let's see this formula. Whether it's, because we know it's a 6 electron,
Yep.
so we are going to verify this one. 2 times 1 is 2 plus 1 3.
Yep.
And look, 6. We are getting 6. That's correct.
So that's like the
Yes.
p orbital. Yep.
Mm.
Okay.
For d orbital, what is the value of L?
We said 2.
2. So 2 times 2L plus 1.
Yep.
So I'm writing 2, and 2 times 2 is 4 plus
Yep.
1 5. And
Times
we are
2 is
10.
10.
That's correct.
Yep.
So why I use this one? Because I know that the number of orbitals for any value of L depends, the formula is this. And each orbital accommodates 2 electrons. So I multiplied by 2 to get the maximum capacity of electrons. Is clear?
So this formula 2 times 2L plus 1 is equal to the total number of electrons.
The maximum number of electrons. Okay. And this 2L plus 1, this represents the number of orbitals.
Say again? I'm sorry.
2L plus 1, let me write this. 2L plus 1
Mm-hmm.
is the number of orbitals.
Number of
For
orbitals, okay.
any value of L. And like any value of L means any subshell, okay?
L is the subshell.
Yeah, and 2 times 2L plus 1 is equal to maximum number of electrons,
Mm-hmm.
maximum electrons in any subshell. In any subshell. Now let's see for G. Of course, G do not exist, but let's try it theoretically, okay?
Yep.
What is the value of L for G orbital? Of course,
We said
theoretical.
4,
but-
right?
Hmm?
It could be 4.
Is it 4?
Right?
You're right. So it's going to be L is equal to 4. So can you tell me maximum electrons in this G? If any time in future we need G orbitals.
So if L is equal to 4, then that means the maximum number of electrons is 2 times, 2 times 4 plus 1. So it'd be 2 times 4 is 8, plus 1 is 9, and then times 2 would be 18. Be
How much?
18 electrons.
18.
2
Yes,
times,
you're right. Because maximum electrons. 2L plus 1, 2 times 4 plus 1, 9 times 2, 18 electrons.
Mm-hmm.
It's clear? So we can get that one theoretical by using that formula. What next?
Hell yeah. The that formula
Okay, but in this case we don't need that one. Sorry, I explained, but maybe in future it will work. Because they already told us the number. 1s orbital, 3p orbitals, 5d. So just because already they had given 1, 3, 5 and 7, so just multiply by 2.
Mm-hmm. So
Because they already have told us. Otherwise, if they don't tell, then we can do that.
in let's see, so part B it says 3p orbitals. So
Because already saying 3, like a 3p orbital, because p have 3 orbitals. So 3 times 2 is how much?
6.
6. What about 5d orbitals?
So it'd be
Just double it.
10.
10. What about 7f orbitals?
14.
14. Because each orbital can accommodate 2. Each orbital can accommodate 2. This is orbital.
Oh,
Each orbital can accommodate maximum 2.
okay. Okay.
So if there are 3 orbitals, 2, 2, 2 will be 6, right?
Mm-hmm.
Like this. Okay, now let's go to 7.65.
Says make a chart of all allowable orbitals in the first four principal energy levels of the hydrogen atom. Designate each by type, for example, sp, and indicate how many orbitals of each type there are.
Okay, let's start 7.65. Okay, what they are saying this question, in this question is make a chart of all allowable. So you can make a chart like N, L, ML, and S. Okay, 4 values. And make a chart for all allowable orbit in the first 4 principal energy levels. What are the first 4 principal energy level means? N is equal to, what is the value in this case? Can you tell me now?
It could be 1, 2, 3, or 4, right?
Yes, 1, 2, and 3, and 4. Only 4. So you start with the 1. And first write all, keeping the N 1, first complete the chart, okay?
Mm-hmm.
Then go to the same thing with the 2, then for 3, then for 4. So let's start with the N is equal to 1. What is the possible value for N?
Let's see. So it'd be 0, right? Hold on.
Because in hydrogen, first of all, electrons can go into 1, second, third, because during excitation, right?
Mm-hmm.
If N is equal to 1, N is equal to what? L, what is the possible value of L? It's going to be 0.
0,
Because
right?
L value is, I told you L value, possible value is 0 to N minus 1.
Uh-huh.
So 1 minus 1 is also 0, so only 0. What about ML value possible?
So it'd be just 0.
0. What about S value?
The spin would be plus 1/2 or negative 1 minus 1/2.
So you can make two line, okay? All other things are going to be same 1, 0, 0, but changing their spin, right?
Mm-hmm.
Now again keeping the 1. Again keeping the 1. Okay, is no, now because I don't think any other possibility is there, am I right?
Right. Yep. Yeah, that's it.
I don't think any other possibility is there. So that's finished. So now let's go to the 2. Now you fill this one. Tell me what.
Alright, so we would have
Starting from the lower to, we will go to the next like this.
okay. So for
The L value I told you 0 to N minus 1.
0 to 1. So it'd be minus 1, 0.
No, first tell me L value. Possible L value for this.
So if n is 2, so it'd be 0 to 1.
0 to 1. So I'm writing 0. First I'm writing 0. What is the possible value of ML? If ML is equal to 0. Sorry, if L is equal to 0, what is the possible value of ML?
0.
Just give me one. Just one. Okay, ML is equal to 0. That's correct. What about possible values of S?
Plus 1/2 or minus 1/2.
Okay, so you write like this. 2, again, 0, 0, and minus half. Now, again I am writing, is there any more possibilities for 2?
Yeah, so we could do L is 1.
1. And again repeat the same thing. What is the possible value of ML?
ML is equal
ML
to...
is from minus L to plus L. You already know. ML is equal to minus L, 0, and plus L. So because it's a 1, so you can have minus 1.
Mm-hmm.
Okay? And again we are going to have 2 values. You are also going to have 0. Then you are also going to have plus 1. Right?
Right.
And each minus, this minus 1 has minus half and also have plus half. Right?
Right.
0, 0 also have minus half and plus half. Plus 1 also has plus half and minus half. Am I right?
Right. Yep.
This one. So this, the other one I'm keeping same, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1. It's clear?
Yes.
Because if it is 2, the possible value is going to be 0 and 1. 0 and 1.
Right.
What about if it's in third orbit?
So the third one would be, it could be 0, 1, and 2, right?
Okay, third.
For n
0,
equals 3,
yes,
it could
that
be.
means 0, 1, and 2. Am I right? You are right.
Mhm.
Okay. And what about the ML value?
Okay, so ML could be, when it's 0, it would be 0.
So only two possibilities, plus half and minus half. Am I right?
Minus half, yep.
What about if it is 3 and 1? L is 1. Now you have 6 possibilities, because first
Yep.
you will take minus 1, plus half, and minus 1 again, minus half. Now you are going to take 0 and again repeat the same thing I'm writing together, okay?
Mm-hmm.
Plus half, 0, and you will get like this one. Now, and then you will go to the plus 1.
Plus
0,
1
0.
right over here, yeah? Same things
Yeah.
on the spin.
Plus 1, and again minus half and plus half, okay? You are going to have like 6 possibilities. What about when it is 2?
When it's 2, it could be minus 2, minus 1, 0, plus 1, or plus 2. That's the
Minus 2, minus 1,
1.
0, plus 1, and again you will, with each of them you will repeat that one, am I right?
Yep.
Is it clear?
Yes. So there's a lot of combinations with that one. With that
Yeah.
with that principal
So that's there to
quantum
do.
number.
Okay.
Okay. And then for 4, for n equals 4, it would be, the options in L would be 0, 1, 2, and 3, right?
Yes.
And then it would be
Because if if n is equal to 4, possible value of n is going to be 0, 1, 2, 3.
Mm-hmm.
And for 0, of course, it's only 0, 0. For 3, is going to minus 3, minus 2, minus 1, 0, 5, 9 possible values. And for 9 possible values, you have again twice value, minus half and plus half.
Yep.
Is it clear?
Yes.
Okay.
Yep.
What about which one we did now, right now?
We just finished 7.65, so left we have 7.79, 81, and 94.
Okay. Okay.
But
7.79. Indicate which of the following sets of quantum number in an atom are unacceptable
this,
and explain why.
when I saw
This
this
question is good, very good.
Yeah, when I saw this question, I thought of all those ones of those quizzes that you made, and we would go through them. And about like Hund's rule, Pauli exclusion principle, and Aufbau, right?
Yes. Indicate each of the following sets of quantum numbers in an atom are unacceptable. So let's start with the A.
Okay.
And you are going to tell me. And also remember, all of them are in the same order: N, L, ML, and S. So 1, 0, half, half. Okay.
All right. So right off the bat, I see something red flag with M sub L as 1/2. It can't be 1/2.
Because ML is not a fraction. It's only 0, 1, 2, something like that. Right?
Yes.
So this is wrong, not possible. So we know that. So because ML value is whole number value starting from 0, okay?
Mm-hmm.
And also, if L is equal to 0, ML should be 0. If L is equal to 0, ML is going to be 0. Because we know that ML is equal to minus L to plus L passing through 0. And we already know L is equal to 0, so ML is equal to 0 in this case. What about the next one, B?
This
What's wrong?
next one looks good to me. It's got
Mhm.
n is equal to 3, L is 0, and then M sub L would be 0, and then positive 1/2. So it looks like it works. Is that
Yeah, that looks correct to me. Okay, what
so?
about
That was what, B?
C?
Okay, so C is
2, 2,
1 and plus
1
1/2.
plus half.
All right, so um, looks like the L number, they can't be the same, right? N
Yeah,
and
they
L
always
can't be
go to
the
one
same.
S. Yes.
Okay.
So this is wrong. It can be 1, but not. And when it's 1, then this one is wrong. Because the L value is going to be 0 to n minus 1. So 2 minus 1 is 1, not going to be 2. What about the D?
All right,
4, 3, minus 2, plus half.
This one looks good.
No? This looks good. Yes, you're right. Because the L is 1 less than this one, it's okay.
Yep.
And this is, if it is 3, then minus 3 minus 2 is going to be there, and that's right. What about E? That
E.
looks good.
E does not look good because of the spin. It's not.
So you're right.
It's
Very
not
good.
either plus 1/2 or negative 1/2.
Okay, that's right. This is correct. Okay, this is also possible, but this is not looks good. Okay, because spin is only two values, plus half or minus half. Okay.
Yep, that's right.
Now let's go to the atomic number of an element is 73. Is this element diamagnetic or paramagnetic? Okay.
All right, so 73 is tantalum.
Okay. First thing is, if we because we have to fill this thing. If you forget that one, so I told you the order to memorize like this one. 1, make circle 2, then 3. But sometimes we don't remember the order, okay? So, but we can make this thing very easily. If it is 73, maybe we need it.
Yeah, the teacher
After
took.
4, you can make again 4 and then decrease this thing up to 2. And 2. We don't make 1 up to here. Why? Because if you look, this is 1, 2, 3, 4, 5, 6, 7. We have only 7 period in the periodic table. We don't have 8 period.
Yep.
And now the first one is S. Second, all of them are S, 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 S. Next is P, 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 all of them. P, 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 P. And this one is D, D, D.
And the last two F.
F. Now let's start writing the number.
Okay.
Because the order you will go like in the cross, like this one, like this one, like this. I am making like a parallel line crossing these circles. And you start from the top, these arrows. Okay, starting from the first top, 1S, and right? Then come 2S, like you are passing through here. The first arrow passed through 1S. Because 1 I am taking this one. Otherwise you can put 1S, 2S, 3S in front of 3, 4, 5 like this. 7. And then we have like a 2p, 2p, 3p, 4p, and so on.
Mm-hmm.
So let me have right 1s, 2s, 2p, then it comes 3s, then comes 3p, then comes 4s, then 3d, then comes 4p. Okay, what comes after 4p? 5s. After 5s we have 4d, and after 4d we have 5p, and then 6s, then 4f, then 5d, then 6p, then 7s, then we have 5f, then 5f, 6d, then 7p. Am I right? Now let's fill this thing.
Man, you're good. I gotta.
Mm.
I was losing track and falling way behind.
Okay. So I'm just not writing up to here because I know up to 4s2 is going to be 20 count of electron. And if I put 3d10 also, is going to be 30 electrons. So 30 electrons we already have added. So now I'm moving further after 30. What is the atomic number they are saying?
73.
73. So 30 we already have filled. So minus 30, now we have 43 more. Am I right? So I'm going to put 43 more. 4p is 6. 5s is 2. And 4d is 10. Okay?
Mm-hmm.
So 8
That's
and
18.
18. And 5p is 6. 18 and 6, 24. Am I right?
Yep.
24 and 6 has 2. 26. Am I right?
Yes.
So 30 and 26, how much? 56. So now let's go after the 56. How much left now?
We need like 17.
73 minus 56. 13 minus 6 is 7.
17.
And 17. So let's go further after 6s. 4f, 14. Now we have 14 and 3 left. Am I right? So 5d3. Am I right?
Mm-hmm.
So all others are already filled. Only 3d is incomplete. Am I right?
Right.
3d has how many orbitals? 5d, sorry.
5 orbitals.
5 orbitals. And according to which rule I have to fill them separately and with the same spin?
Hund's rule.
Hund's rule.
Is it?
So 1, yes, you're right. 1, 2, 3. So how many unpaired electrons are here?
3 unpaired.
3. Even if it has one unpaired electron, it's going to be paramagnetic. Even if it has a single unpaired electron. So because we have unpaired electrons, so we call it paramagnetic. Now look the answer there. Your answers there.
If it was diamagnetic, is that like
All of them are going to be paired.
Okay. So even if it
And
was
even
only
if it is one single unpaired, then it's paramagnetic.
okay. So like if all of these
Unpaired is still paramagnetic.
okay. So diamagnetic would for the 5d orbital would have to be full. There's only one element that would be
No.
No?
Full, yes, full like 10.
For 10.
If it is not 10, then it's going to be paramagnetic.
Yeah, it
What
says
is the answer there?
it says paramagnetic. It says
Okay.
since the atomic number is odd, it is mathematically impossible for all the electrons to be paired. There must
Yes, and also like if they are not, this I explained for this purpose, but otherwise if it is 73, it's odd. So odd cannot be paired, am I right?
Right.
So we can also give directly saying like that, but in case if it is even, then you have to check it.
Got it. Yeah.
Okay, one more question, because not from here, but I was looking this one, so I'm going to ask, hold on this one. We determine the energy level by making this diagram, alright? By making this diagram. Now suppose Hold on just 1
My
minute.
bad.
Uh, Suppose if I ask, find out which one is higher in energy, which orbitals are, arrange orbitals in order of decreasing energy, decreasing energy, decreasing energies. Suppose only two or three are there, so it's not feasible to make the whole diagram. Suppose I'm giving you 6s, I'm giving you like 4f, 4f, I'm giving you 6p, and I want you to predict, uh, let's write 5d, sorry, 5d. So how I can directly determine without making the diagram? So look, that's the energy depends on this one.
Mm-hmm.
Formula is n plus L value. N plus L value. Greater the n plus L value, greater the n plus L value, more will be the energy, more will be the energy of orbital. Actually, energy of electrons in that orbital, energy. And the other thing is, if n plus L value is same, then greater n value will be of higher energy, will be of higher energy. Now let's start with this one. I am writing 5d, n plus L value.
Mm-hmm.
N plus L value. What is the n value here for 5d?
N is equal to 5.
What is the L value for this?
2. 0, 1, 2.
Yes, 7. Total is coming 7. Now let's write 6s. What is the value here?
N is equal to 6, and L is equal to 0.
6. What about 4f?
4F. Okay, so N is equal to 4, and then F is, so SPDF, so it'd be 3. L is equal to 3.
7.
Right?
Okay, total is 7. Which one has the lowest energy out of these three?
6S.
6s. Which comes next?
Uh, 4F.
Why 4f? Because 4f and 5d have the same total.
Mm-hmm. So just like you explained here, it says if N plus L is the same, then the greater
right.
then the greater N
If
value.
n plus L value is same, then you
higher
look the
energy.
n. The n smaller n, lower energy. Higher n, so in this case it comes 4f. And then comes 5d. Now let's see 6s, 4f, 5d. Whatever we have made here. Look here. 6x in the beginning, then comes 4f, and then comes 5d. Is clear?
Oh wow.
So if it is only 2 and 3, so do not waste time in making those things. Just write n plus L value, and you can directly tell which one is higher energy, which one is less energy. Is that clear?
Yeah. Thanks for explaining that. That's good.
Okay, now the next question is 7 point, the last question here in this case, 7.91. What is the Abba principle? First tell me.
The Aufbau principle to obtain the ground state electron configuration. So it's going to be, I think, is this about building the building a configuration from the lowest energy level and then going from lowest to
Yes.
highest.
Yes, you're right. And you know, I gave you an example. Like suppose a group of students are going for picnic or some tour,
Mm-hmm.
and they have limited money. They don't want to spend too much money on spend for taking a rest at night in the motel. The first floor has cost of $50 per night.
Oh yeah, yeah.
Next at $70,
Right.
and the higher is start 700.
Yeah, like the penthouse, the penthouse suite
Yeah,
up at the top.
and students do not want to waste money because they want to explain to each other. Like, so where they are going to occupy first?
They're gonna occupy the first floor first.
First floor. When there is no capacity, no vacancy here, then they will go to the 70. Then
Yep.
if it is full, then they will go to the next one.
Yeah.
That's the Alpha principle. Electrons are also very smart. They don't want to spend too much energy. First, they are going to occupy the lowest cost orbital, lowest energy orbital. Clear?
Yeah, that's
the Alpha principle.
I'm definitely gonna remember that one for sure.
Okay?
Is the hotel vacancy.
Use the Alpha principle to obtain the ground state electron configuration of selenium. Look the atomic number of selenium in the periodic table.
34.
34. So you have to write the electronic configuration of selenium.
Okay.
Starting from 1s2. What come next?
All right. If it's 1s2, we have 2s2, right?
Mm.
2p6,
Mm.
3s2,
Mm.
3p6,
Mm.
4s2.
Okay, one more thing.
Is that true?
Suppose somebody is right, 3s, 4s2, and then
Mhm. You want let's see. Is it
3d.
the D? Okay, so it starts at 3, right?
Okay.
So
Let me one more thing. I'm going to explain this thing. We can write like this, but if somebody write like this, they are writing 3s2, 3p6, and also 3d here. So it's not wrong. It is also correct. But you have to fill this one first, and then come back here filling this one.
mm,
That's also not wrong. So be careful. Somebody write 3d6 and then 4s2. It's not wrong. It is correct.
okay.
Because they are writing in order but still filling the 4s first, right?
hmm
So 30. So now what next come?
So where are we at? We have
30.
3.
So far we have 30.
So if we're at 3d10, and then it would be 4p, 2, 3, 4, 4p4. Is that true?
Okay, excellent. That's right. Okay, without making diagram, tell me why 4p is of higher energy than 3d
Why
in terms
is
of quantum numbers.
4p higher energy than 3d?
3d.
Okay. Okay, so 4, the principal quantum number is 4 here, and it's 3 here.
Mhm.
And then L, let's see. So L is 1, so their N plus L value here is 4 plus 1 is 5. And then this one here is 3, and D 0, so S, P, D, so that's 2. So 3 plus 2 is 5.
Mm.
Okay, so then N is 4. So because N is
Yeah, lowest value. So less value than, because the total is coming same, then you have to look the lowest value of n. On the basis of that, 4p is of lower energy than, 3d is of lower energy than 4p. Is it clear?
yes.
Okay, now let me ask something. Possible correct value. And whichever is wrong, you have to tell me, okay? And also I'm going to write like N, L, ML, and S. I'm writing here. 2, 1, 3 plus half. Is correct or wrong? If it is not correct, what is wrong?
This one here.
This one. What are the possible values I have to put here?
The possible ones would be -1, 0, and +1.
Plus 1. Okay. Now I'm writing here. 2, 0, -1, minus half. Is it correct?
No, this would have to be 0. Is that right?
This has to be 0. You're right. Very
Okay.
good. Okay. This is wrong. You have to do 0. Now I'm putting here.
Yes. We can use this is a combination. Acceptable.
No,
Wait,
this
no.
is not.
This one.
This is wrong.
Okay.
2 is wrong. Because the n value cannot be equal to n.
Right.
At least one less than this one.
Got it. I need it.
Clear? It should be, it can be 1, it can be like 1 and 0. Am I right?
Mm-hmm.
It cannot be like a 2. Is it clear?
Yes. Yeah.
Anything else you want to ask?
I think we could definitely do a session maybe are you going to be busy on Sunday at all?
Sunday, what time you want?
We could do any time. Or actually I'll be watching I'll be busy from 8 p.m. to like 11. Maybe any time before like 8 p.m. if possible. If not, then we could do like maybe Monday or Tuesday.
Oh, you are going from 8 p.m. to after that. So that's okay, no problem. We can do it as either 11 a.m. in the morning
Yeah.
or 5 p.m. in the evening, whatever
Yeah.
you like.
Either one works for me. I'll be up. So really, whatever works best
So,
for your schedule.
okay, so 11 a.m. in the morning, okay?
Yeah. Yeah. If we could do some more practice with
Yeah, I'm going to upload, I have those questions related, I'm going to upload that one.
yeah, we could go through
And
like
I'm
your
going to,
worksheets.
because I understand this is what type of question they are going to give you.
Mm-hmm.
So they are going to practice more and more and don't worry about it.
Yeah.
What do we in the next test? What chapters?
I think it's gonna be chapter 7, 8, and 9. I have to check, but I'm pretty sure it'll be the next 3 chapters because you said that we have to by the end of the semester we have to have finished 1 through 12, and it seems like each exam is 3 chapters apiece.
Mm-hmm.
So I'm assuming he's gonna be doing one chapter a week, and he goes through it super fast.
But also because in the final exam they are going to cumulative, am I right?
I believe so. Yeah.
So in that case you have to also review whatever you already had given.
Oh
Okay?
yeah. Yeah.
So keep review when you are doing for the next third test. Also look the other test a little bit, okay?
Will
So it's
do.
not going to be too much pressure at the end.
Oh yeah. Yeah, I'm saving everything that I have, all the paperwork and stuff like that. Yeah.
Okay. So on Sunday at 11 a.m. Okay?
Yes. Yep, Sunday at 11. That'll work. Thanks a lot for everything, Jafri. You have a
No
great
problem.
evening.
Take care.
Thank you.
You're welcome. Bye.
Bye-bye.